Welcome to part 2 of the MOJO Project. This video asks the question, how common are solar systems like our own in the context of what we know about extrasolar planets, planets around other stars? To start off, we all know and love our solar system. We've got 8 planets. We've got 4 small rocky planets, the terrestrial planets close to the sun, and 4 giant planets farther away. 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. Now the question is, if we took the solar system and put it around another star and observed it with present-day Earth technology, what would we see? And it turns out if we do this little experiment, the only planet that we could see is Jupiter. With a long-term radial velocity monitoring program, we could detect Jupiter. We could measure its mass, we could measure its orbital size, and its orbital shape. But that's it. We could detect Jupiter. We couldn't detect any of the terrestrial planets, at least for now, or the more distant giant planets. That's all we got. So the search for other solar systems for now is search for Sun-Jupiter systems. Yet among the known planets, we can still ask the question, how common are Sun-Jupiter systems? To do this, the first step there is to ask how common are suns, the first part of that equation. So if we take a ball 30 light years in size around the sun, there's about 400 stars within that ball. And this plot shows the distribution of the different types of stars. Now, our sun is a yellow star, a G star. And what you can see is there's plenty of yellow stars within that ball. But most of the stars that are close to the sun or within the whole galaxy are small red stars, M stars, sometimes called red dwarf stars. So the fact that we have a yellow sun instead of a red sun already puts our solar system in the minority, in about the 10% minority. We have about a 10% chance within the galaxy of having a yellow sun instead of a different colored sun. The next step is to ask how common are Jupiters. And what this plot shows is a distribution of the known planets around other stars. So each dot here is a specific planet around another star. The vertical axis shows the planet's mass, and the horizontal axis shows the size of its orbit. The color corresponds to how it was found, the technique used to find it. And we can kind of divide this plot into different clumps. There's clumps of hot Jupiters, of more normal Jupiters, and of super-Earths. And, well, first of all, you can also see that the planets within our own solar system, Venus, Earth, Jupiter, and Saturn, they lie mostly outside of these clumps. We can't find planets just like Venus or Earth yet. We can't find Saturns yet either, but we can now start to find Jupiters. And so from these different clumps, about 1% of stars like the sun have a hot Jupiter, about 10% have a normal Jupiter, and about 50% have a hot super-Earth. What does that mean? It means the probability of us having a Jupiter is about a 1 in 10 shot, about a 10% shot. The next question to ask is, what are the odds of our Jupiter having an orbit like our Jupiter has? What you see here in yellow are the orbits of some of the giant planets that we see around other stars. So Jupiters around other stars. You can see they often have very stretched out orbits or much smaller orbits than our Jupiters, which is shown in red. There's only about 1 in 10 planets like Jupiter around other stars that have orbits like Jupiter's. The fact that our Jupiter has a wide, nearly circular orbit is about a 10% probability again. Now finally, there's one more thing that we can look at, and that's not what the solar system has, something it doesn't have. About half of stars like the sun have close-in super-Earths, and we don't. Right? That's about a 50% shot right there. So putting all these probabilities together, we can ask the question, how common are solar systems? And so based on what we know right now, there's a 1 in 10 chance of having a yellow sun like we do. There's a 1 in 10 chance of having a Jupiter at all. There's a 1 in 10 chance of that Jupiter having a wide, nearly circular orbit like our Jupiter does. And about a 1 in 2 chance of not having a close-in super-Earth. So adding those all up, there's about a 1 in 2,000 chance of having a solar system among nearby stars. Now, within the galaxy, there's about 500 billion stars. So that gives us several 100 million candidate solar systems. But remember, these are just candidate Sun-Jupiter systems. It applies to the real solar system. There's many other characteristics that represent the real solar system, like the orbits of the other planets. And so when we take the whole solar system as a whole, it can only be less likely than this. At the same time, there could easily be, certain characteristics that are more common. Like the occurrence of planets on orbits like Earth's, there may be a lot more of those than there are Sun-Jupiter systems. Right? So putting all those together is a whole other thing. Finally, the contribution of the MOJO project to this study is that we've written several reviews to try to put the solar system in the context of extrasolar planets, in particular from the point of view of planet formation.
MOJO.